Today we're going to continue with section 10.3, so more with the parabola. We're going to graph parabolas and write equations in standard form. So notice that this first example is asking us to graph y squared plus 2y plus 4x minus 7 equals 0. As we can see, this is definitely not written in standard form, so our first step is to get it into standard form so then we can graph our parabola. So remember, to get it into standard form, I want the squared term on one side and I want the non-squared terms on the other. So the fact is, in this particular problem, it looks like it's the y term that's going to be squared. So that means that anything that doesn't contain a y, I'm going to be moving it over to the other side. So we're going to have y squared plus 2y, and that's going to equal, notice to move the 4x over, I'm going to have to subtract it. And to move the 7 over, I'm going to have to add it. So that's going to equal negative 4x plus 7. And so now I'm going to be completing the square. I'm going to look at the number that's in front of the non-squared term on the left side. I'm going to divide it by 2, and I'm going to square it. Well, 2 divided by 2 is 1, and 1 squared is 1. So that means that I am adding 1 onto the left. And so if I add 1 onto the left, I'm going to have to add 1 onto the right. So on the left, when I then go ahead and factor, this is going to turn into y plus 1 quantity squared. Notice that over here on the right, when I combine like terms, I'll have negative 4x plus 8. And so then the last step on the right is to factor out a GCF. So what does negative 4 and 8 have in common? Well, they have a negative 4 in common. So when I factor that out, that leaves you with an x minus 2 in parentheses. And now I have my standard form equation. So to identify the vertex, remember it's always h followed by k. H is always connected to x. So since x is on the right, I'm going to change the sign so it becomes positive 2. And then my k value, I switch the sign. So my vertex is at 2, negative 1. Because my y term is what's being squared, that tells us that I know that my parabola is going to be opening either to the left or to the right. Because the term that is, or the number that's in front of my non-squared term is a negative, realize that 4p equals negative 4. So that means that p is negative 1. Because our p value is negative, that means that our graph is going to be opening to the left. And so that means that if I have my parabola opening to the left, I know my focus point is going to have to be to the left inside of that parabola. So moving left tells us that we're going to move the first number in our vertex, and I'm going to go 1 to the left. And so 2 minus 1 tells us that our focus point is going to be at 1, negative 1. I know that I need to have a vertical line in order to then have it not intersect the parabola to create my directrix, which means I need the equation x equals from my vertex, if I'm moving then the direction or the length of p 1 to the right, well, 2 plus 1 tells us that our directrix is at 3. Okay, so I know that if I start plotting that information, 2, negative 1 is my vertex, 1, negative 1 is my focus, x equals 3 is that vertical line, which is my directrix. So the only other piece of information that I need is I need to have the two endpoints of the lattice rectum. So remember, the length of the lattice rectum is going to be the absolute value of the number that was attached to the non-squared term. So absolute value of 4 is 4. So from the focus point, I'm going to cut that in half. That means I have to go up 2. And from the focus point, I have to go down 2. That creates that length of 4. And then now when I connect the focus point to the vertex, I get my parabola. Okay, same idea. Let's go ahead and graph this. So I'm going to understand that my y term is what's being squared. So I'm going to keep the y terms over here on the left. I'm going to move anything that doesn't have a y over to the right. That means I'm going to have to subtract x as well as add 72. So that equals then negative x plus 72. Okay, I want to start completing the square on the left-hand side. However, because there's a number in front of the y squared, I have to take out that GCF. So then that gives us y squared minus 12y, and that's what I'm now going to be completing the square with. So since I'm going to complete the square once, I'm going to have to add something one time onto the right as well. So I'm taking the number that's connected to the y, I'm going to divide it by 2, and I'm going to square it. Well, negative 12 divided by 2 is negative 6. Negative 6 squared is 36. But remember, it's not 36 that I'm adding over to the other side. Because we took out that GCF of negative 2, negative 2 times 36 is going to give us the number that gets added. So that would be negative 72. So now I have negative 2 on the outside. I can factor that trinomial. That would be y minus 6 quantity squared. And that's now just going to equal negative x because the 72 and the negative 72 cancel. Still not in standard form though, because I need the squared term to not have a number in front. So I'm going to divide both sides by negative 2. And so my standard form equation is y minus 6 quantity squared, and that equals 1/2 times x. Okay, so if I want to identify the vertex, remember there's no number in front of or in parentheses with the x, so that would be 0, but there is a number in parentheses with the y, so I changed the sign, and so 0, 6 is my vertex. Notice that the number that is connected to the non-squared term, if I set that equal to 4p, when I divide both sides by 4, it's the same thing as taking 1/2 and multiplying by a fourth. So that gives me a p-value that's very, very small, but it's 1/8. So because that p-value is a positive number, I know my graph either opens to the right or it opens up. When we're dealing with a y term being squared, that tells us that our graph is going to be opening to the right. And so that means that if my parabola opens to the right, my focus point has to be even farther to the right because it's inside of the parabola. So because I'm moving to the right, that means that it's the first number in my vertex that's going to change. I add on that length of p, so 1/8, comma 6 is my focus point. I know that my directrix is going to be a vertical line, so that's x equals, because the vertex was at 0, 6, I'm moving 1/8 to the left, so that gives us then from 0 minus 1/8, that gives us x equaling negative 1/8 for our directrix. Okay, the length of the lattice rectum is going to be the absolute value of that term in front of the non-squared. So that's going to be 1/2. Okay, so that tells us then if I start plotting my points. So here's the thing. Once again, if it's not going to be that you're going up and down by ones for your tick marks on your graph, you need to label it. So I am going to be going up and down by ones for the y, but for the x-axis, I'm going to have everything be going up and down by 1/2. And so I'm clearly labeling that. Okay, so 0, 6, 1, 2, 3, 4, 5, 6 is up here. That's my vertex. My focus is 1/8. So that means that it's going to be super, super close to the vertex. My directrix is going to also be super, super close to that vertex because we are only going 1/8 of the way away. And then because my length of the lattice rectum is 1/2, I know that that means that 1/4 is what I want to move up and down by. So from the focus point, I go up 1/4, and from the focus point, I go down 1/4. So notice that this parabola is a very, very small parabola, but that would be then my graph. So take a second, pause the video, see if you can at least get this graph into standard form, and then also, if you want, you can graph it. So pause it, try that. So hopefully we get the equation x plus 3 quantity squared equals negative 8 times y minus 1. So notice that we had an x squared term. That means it opens up or down. Because the value that's in front of the non-squared term is negative, it's opening down. Hopefully that was okay. Last problem that I want us to do, write the equation in standard form. We're given that the vertex of the parabola is 0, 0. Length of the lattice rectum is 14, and then the parabola opens to the right. All right, so when we know that it opens to the right, that tells us that we have to have our y term to be squared. Because our vertex is at 0, 0, I know that it's just going to be y squared. We'll have to find what that number is. Because there's no number in front or with it's 0, 0 for the vertex, that means there won't be a number with the x. So really now all I have to do is worry about finding that number that's connected to x. So that's where this length of the lattice rectum is going to come in. I know that because my parabola is opening to the right, I know that my p-value is going to be a positive number. All right, remember the length of the lattice rectum is the absolute value of 4p. And so the absolute value of 14 would be 14. So technically 4p equals 14. I don't really even care what the value of p is. The number that represents 4p is the number that is going to be attached to the non-squared term. So y squared equals 14x. There is my standard form equation. So that's us graphing parabolas and writing equations of parabolas in standard form.